Greetings everyone. Today we're going to explore the basics of function notation. We do have a note sheet for this, but as always you can jot it down in your notebook. First, let's define function. A function can be thought of as a rule that assigns a number to a variable. So you've actually done this before, where if I told you x was 5, you'd plug 5 in for x and, depending on the scenario, possibly solve or do something else. So what's different? Well, now the way it looks is going to be a little different. So as you can see in this example, the first part is the letter, in this case f. F is the name of the function. Now its name can be any letter in the alphabet. I could write H, G, M, any letter is okay. The expression is called the rule of the function. What's the rule we're following? What's the rule we're going to use to calculate? The letter in parentheses is just denoting that the variable is present in the rule. So you can see the x here. It's just saying, hey, yeah, we're going to plug something in for x. And how we say this, if I read this entire left side, I read it as f of x. So naturally we want to see f parentheses x, but we read it as f of x. Now, when we think of a function rule, let's think back to elementary school. You've probably seen some different scenarios, possibly in English class, possibly in math class. If we input a word or a number, in this case a number, and we apply the rule, the output is something else. So in this case, if I plug a -2 in for x and I calculate, my output is a -6. So imagine it being like a function machine. Something comes in and another value comes out. On the front of your note sheet, let's use this idea of a function machine to help us calculate the first couple of examples. We want to illustrate f of 2. So you'll notice instead of f of x, it says f of 2. So you'll notice that the x has been replaced by a 2. So it's just telling me, hey, change the x's to 2's. So the rule says 3x plus 4. Well, instead of x, we're told to plug in a 2. That's the only difference here. We're just being told what to plug in another way. And then we can calculate 3 times 2, 6, 6 plus 4, 10. Don't forget your rules of PEMDAS. We're going to multiply before we add. Let's try again. This time, we're going to calculate f of -1. That means in my rule, instead of x, I'm plugging in a -1. 3 times -1 plus 4. -3 plus 4 is 1. Now we don't need to draw a little machine every time, so I think we're comfortable enough that we know what we're being told to plug in. It's saying f of 3. So I look at the f function, and instead of x in the rule, look at the rule only, I'm going to replace x with a 3. See how I substituted that in? That means f of 3 equals 6. Let's go again. This one says g of 3. Oh, it's a different rule. We're saying use the g rule. Okay, the g rule says -2x plus 1. So instead of x, we're going to plug in a 3. And then we're going to calculate. Multiply first, then add. G of 3 equals -5. Let's take a look at this one. F of -2. We're going to take the F rule, and instead of x, plug in a -2. -2 plus 3 is 1. So the calculations will be kept pretty simple. It's more of the idea of what are we plugging in and into what rule. That's what we need to work on. Pick the G rule and plug in 0. Pick the G rule and plug in 0. Now you'll notice I use parentheses. You could also use a multiplication dot because when things are next to each other, that implies multiplication. Either way, we arrive at the same solution. G of 0 is 1. Notice this one. We're going to treat this like two separate problems. Let's deal with the left side first. F of 2. We're going to take the F rule and instead of x, plug in a 2. See how I replaced it? That gets me to a 5. Let's look at the right side. G of 1. We're going to take the G rule. Instead of x, plug in a 1. Negative 2 times 1 is negative 2, plus 1, negative 1. So what's different on this problem? There was a plus sign in the middle of our rules. So in the end, we're going to add them together. 5 plus negative 1 is 4. Let's try again. I'm going to treat it temporarily like two separate problems. Let's start with G of negative 1. The G rule and substitute in negative 1. Negative 2 times negative 1 is 2. 2 plus 1 is 3. Let's look at the other side. F of 1. We're going to take the F rule and instead of x, we plug in a 1. Nice calculation of 4. This rule said in the middle of the two to add them together. 3 plus 4 is 7. Let's go again. F of 6. Take the F rule and plug in 6. So the difference here is it's a little more involved. I'm going to set it up first. Instead of x, I put a parenthesis. And instead of a parenthesis, I'm going to plug in a 6. Well, let's calculate. Half of 6, negative half of 6, excuse me, would be negative 3. Negative 3 minus 3, negative 6. So even if there's fractions, negatives, we follow the same process. G of 10. We write the G function, but instead of x, we're plugging in 10. 15 minus 10, nice easy calculation on this one. 5. So one thing you'll notice, our rules are different on these examples. That's fine. I have to, or whatever you're working on has to give you the rule to use. So just make sure you're using the right one. Let's use those same rules and find f of negative 4. We're going to write the f rule, but instead of x, I'm plugging in negative 4. Let's multiply first. Negative half times negative 4 is positive 2. Right? Half of 4 is 2. Positive 2 subtract 3 is negative 1. So be careful with your negative rules. G of negative 10. Let's write out the G function, the G rule, but instead of x, this time I'm plugging in a negative 10. Look what happens here. I've got 15 subtract negative 10. What's a double negative? The same as addition. So G of negative 10 is 25. Let's use those same rules, but this time we're going to combine our answers in the end. F of 2. We're going to write the F rule, but instead of x, I'm plugging in 2. Negative times positive is negative. Half of 2 is 1. Drop down the minus 3. Negative 1 minus 3 is negative 4. Let's look at the right side. G rule says 15 minus x, but instead of x, I plug in a 1. 15 minus 1 is 14. Now the rule says we want to add our final answers. Negative 4 plus 14 is 10. Let's try it again. G of negative 1. G rule, but instead of x, negative 1. A double negative becomes a positive, so we have 16. F of 10. We want to take our F rule, but instead of x, we're plugging in a 10. Negative times positive is negative. Half of 10 is 5. Negative 5 minus 3 is negative 8. Now the original question said to add those solutions. 16 plus negative 8 is 8. All right, as always, make sure you check out Google Classroom. What is the task to go along with this lesson? If you have questions, let me know. Seek out assistance in the Sabre Center if you need. And until next time, have a good one.